A very good afternoon, everyone. Thank you for joining us for NASTech 2022 Tech Pashala by Future Skills Prime. Future Skills Prime is a joint initiative of Ministry of Information Technology and Electronics and NASSCOM. My name is Amrita from Team NASSCOM and would like to welcome all of you for the next session. Our next edifying session for the day is AI applications and how it is disrupting the job market. Our expert speaker for this session is Mr. Bharani Kumar Depuru, CEO 360 Digi TMG. Mr. Bharani is an alumnus of ISB and IIT with 17 years of experience working in various capacities with companies including HSBC, ITC Infotech, Infosys, then Deloitte, performing consulting for various companies on Industrial Revolution 4.0, implementation, data analytics practices setup, artificial intelligence, big data analytics, IoT as well. He has worked exclusively on many different types of businesses, including IT, quality management, project management, and IT services. 360 Digi TGM is an edtech organization headquartered in India, which provides professional management in emerging tech technologies training across the globe. Welcome everybody once again, and welcome Mr. Bharani Kumar. Hi. Can you hear me?
Yeah, hi. Yeah, absolutely. I am able to hear you, Amrita. Thank you so much for having me here.
I think we are facing some technical issues. Mr. Bharani, can you hear me and see me right now?
Yes. I am
Thank you.
also talking.
Maybe you could switch on your camera once and then we can begin.
Okay. Hello.
Hi. Welcome once again.
Thank you. So can we get started?
Yes, please. Over to you, Bharani.
Sure. Thank you so much. Let me first remove the background while I introduce myself. Thank you so much, Amrita, for having me here. And NASSCOM is doing an amazing job in terms of ensuring that they fill the gap in the industry, right? Skill gap, I would say. So without waiting, I think we should get started. That's me, friends. And I hold a master's degree from IIT and ISB. And I work as a chief data scientist on multiple companies. And we do consulting work for a lot of top-notch companies in the space of artificial intelligence and advanced analytics. And let me get to the slides. A lot of people are asking this question on, hey, what is the difference between artificial intelligence, data analytics, data science, and there are a lot of buzzwords going on. Not just one, two, but plethora of forums are available which explain the difference between these. But let me give my try on this. Okay. So artificial intelligence, data analytics, data science, machine learning, data engineering, MLOps, all these are the buzzwords. And these are not just buzzwords for the sake of, but because the world is moving into this space. Already, a lot of organizations have transitioned into this space. A lot of organizations are still transitioning, but this is going to be the future. Have no doubt about that. Okay, having said that, to successfully venture into this profession of data science or data analytics or AI or machine learning or data engineering or MLOps, etc., one needs to have knowledge about the domain. For example, if someone asks you to build a cancer prediction model, until and unless you have knowledge working in the space of life sciences healthcare, you will not be able to build one. Because what does it take? What are the various elements? What are the various variables? What are the various features which one has to look at to build a cancer prediction model? Now, who will have that knowledge? Doctors, oncologists, radiologists, pathologists, people who work in the space of probably cancer will be having a lot of domain knowledge. However, as a data scientist or a data analyst or machine learning expert or AI expert, you are expected to have some amount of domain knowledge. And that is how you would truly differentiate yourself from the rest of the folks. So always data scientists or data analysts or machine learning experts or whatever be the role in the space of data, they have to work in conjunction with the business folks. It has to be hand in glove. Okay. And what does research has to say with respect to the job openings? US Bureau of Labor Statistics says that there'll be humongous opportunity. Michael Page in India says that 11.5 million job openings will be there by 2026. LinkedIn says that the growth with respect to data science would be from 37 billion to 230 billion dollars. That's a huge market. 2 lakh data scientists will be needed by 2028 in US alone. This is what Glassdoor has to say, that the salaries of data scientists on an average would be 10.5. These are the salaries of data scientists as given by Forbes. Data engineer salaries, data architect salaries, computer and information research scientist salaries, machine learning salaries, so on and so forth. And this is our part of the research. The students who are freshers just out of college are getting anywhere between 4.5 lakhs to 14 lakhs per annum. That means even if you have 0 years experience, that is the value that you can target. Then for someone with 8 to 10 years experience, working in a different domain altogether, say you worked in the space of marketing. So alongside data science training, if you can add marketing analytics as an add-on, then you can expect anywhere between 25 lakhs to 40 lakhs. And that is what we have seen historically. And the research also says the same by various organizations. Okay. But the first things first, what is the difference between artificial intelligence, data science, data mining, machine learning, deep learning? A lot of people ask this question. While it sounds very similar, there is a striking difference between each of these terms. And we'll talk about this. Okay. So before I talk about that, let me just also tell you that we will understand the differences between each of these roles. Data analyst, data science, data engineer, how the things are getting revolutionized in the current world that we are living in, right? So first, let's understand on what is the difference between artificial intelligence, data science, so on and so forth. If humans are doing certain activities, then they will be using intelligence. That's called as human intelligence. For example, if you're driving a car, what do? You apply brakes as need be. You're going to control the steering. And you're going to change gears. So on and so forth. All these things are done manually. You do it in a manual way. If this manual activity can be automated, and if human intelligence can be automated artificially, that's called as artificial intelligence. And think about self-driving cars, autonomous cars, driverless cars. These are all examples of AI applications. So human intelligence, if we can automate that, and if human intelligence is made artificially or automating that, then that's called as artificial intelligence. To build AI applications, we need to have knowledge about data science. Any person working in the space of data and doing some research would be called as a data scientist. Within data science, you have data mining. And when it comes to data mining, one has to have knowledge about, at a bare minimum, they need to have knowledge about unsupervised learning, supervised learning, and reinforcement learning. Of course, reinforcement learning is a different branch, but this is going to be the future. So these are a few things which people have to be aware of. Of course, you have semi-supervised learning, self-supervised learning, so on and so forth. But these are a few things which people must be aware of. Within data mining, there is a field which is called as machine learning. And predominantly, people relate machine learning with predictive analytics, predictive modeling, building predictive models. But it's also related to the other branches. However, predominantly, they correlate this to predictive modeling, building prediction models. Within the field of machine learning, where you end up building prediction models, you have a field called as deep learning. And today, deep learning is synonymous to a term called as neural networks. And no matter what you do, no matter what techniques you apply, at the end of the day, we end up building an AI application. Okay, so let me also tell you that today, when it comes to dealing with complex data, which is unstructured in nature, unstructured data, which includes your videos. Of course, images are a subset of videos. Or if you are trying to work on audio files such as speech recognition system, etc., or if you're trying to work on any of the textual data, people are using neural networks extensively. So it's something like this, that if you want to deal with unstructured data, then it has to be neural networks, which is nothing but part of deep learning algorithms. And deep learning algorithms are a subset of machine learning. Machine learning is a subset of data mining. Data mining is a subset of data science. While these are the differences between the different terms, I also often encounter this question on, all this is fine, but what is the difference between a data analyst, data scientist, data engineer, machine learning operations? What is the difference? There are a lot of different roles which have come to light of late. So let me try to help you all understand the difference. We are in the present. Now, we are here, present. And then whether you are a data analyst or a data scientist or a data engineer or an AI expert, whatever role you're working in, you need access to historical data. right? So everyone will have access to historical data, the past data. So suppose you have access to an organization data. Okay, and this is, say, a company data which talks about the sales across multiple regions. If you're going to take this data and if you're going to visualize, okay, try to come up with some reports, some kind of a dashboard in order to help people understand whether your sales is increasing or whether your sales not was, right? So we're talking about data which is related to past, and then you're trying to make the statements until now. So was your sales in the past increasing until now? Was your sales decreasing? Or was your sales fluctuating? Was there some kind of a seasonality wherein every winter season sales increase, every summer season sales drop because of the nature of your business? So how was your sales behaving in the past until now? If you talk about what happened from the past until now, this is called as data analytics. Okay. And the profession that you're going to work is called as data analyst, or the role is called as data analyst role. So data analyst as a role would work in the space of data analytics. That's all about past until now. Then what about data scientist? What does a data scientist do? Data scientist is a person who will predict the future, will help the organization move from reactive zone to proactive zone. What do you mean by reactive? If you come to know that your sales was down until now, you take an action now to improve your sales. However, if someone can tell me that the way you're progressing, if you progress in a similar fashion for the next 3 months, or for the next 6 months, or for the next 1 year, your sales will decrease or sales will increase. If someone can help me with future, then I can take proactive decisions. If my sales is going to drop and I know that in the next 3 months, my sales will drop, so I can intervene as a business owner and take required decisions to ensure that the sales goes up. Okay. So if you talk about future on what will be the sales moving forward, etc., then that profession is called as data science, and the role is called as data scientist. So data scientist is a role, data science is a profession. However, having said this, while data scientist predominantly focuses on future, and while a data analyst predominantly focuses on what happened in the past until now, I should say that data scientists should also focus on past until future. So whatever a data analyst does, that is something which data scientists should also do. On top of that, data scientist has to predict the future. Right? It's all about, how much time you want to spend to get into this profession, and what is the salary that will really excite you is a trade-off that you need to think about. Because as a data analyst, quickly you can get a job. However, the salaries are not as high as what a data scientist gets. Economies of scope trends. The more you know, the more you get paid. So if you have time, okay, at least minimum you need to spend 6 to 8 months. If you have the time, go choose the profession of data science. Okay. No, I want quick job. I'm okay even with slightly lesser salary. Then data analyst roles is what people prefer. And people who are extremely scared of programming. Oh my God, for a few people, it gives goosebumps the moment we say programming, the moment we say math and stats, right? For those kind of people, again, data analytics might be a preferred choice as opposed to data science. But let me tell you that again, within data science, there are two streams. One stream is called as a research stream, wherein people want to go ahead and do their PhDs, postdoctorates, they want to be in research, they want to come up with new algorithms, etc. At the same time, there is another stream, which is people who want to work in the companies, people who want to work in industries as data scientists. If you want to get into the field of research, which I think 1-2% of the entire workforce would like to get into, then you need to have thorough knowledge about math, stats, and the programming aspects, because you need to come up with a new algorithm and you need to show it that it's working. For that, you need knowledge of programming as well. So you need to be an adroit programmer. You need to be an adroit at math and stats skill. However, if you want to work in the industry, you need not focus heavily on the math derivations, writing huge lines of code. No, that's not what is expected, because no one in interview will give you a pen and a paper and say, hey, write down the math equations. No customer will say, hey, do one thing, show me how many lines of code you have written. No customer would do that in industry. All they would worry about is, are you able to solve the business problem? Yes or a no. That's it. That would be the prime focus. So judiciously choose your profession and which stream you want to go. While there are plethora of opportunities, it's you at the end of the day who needs to do a judicious trade-off and get into one of these required streams. Having said that, there is also data engineering. Let me go there. So data engineering and ML ops are the two roles which are becoming extremely popular. And the salaries are more than what data scientists get. You might ask me, hey, why is that the case? It's simple math once again. Demand supply gap. A few years back, data science was extremely lucrative because there were a lot of openings, opportunities, and less number of people were there. Even today, it is lucrative, no doubt about that. But the amount of demand that we have today for data engineering has just increased, and the number of people who are actually pursuing this profession are very less. And this is the reason why data engineering is fast picking up. Alongside that, we also have machine learning operations, MLOps. I will talk about these two roles by probably moving to the subsequent slides. Okay. All right. So we have a few of our programs which are approved by NASCOM Future Skills. And one of our flagship programs is a certificate program in data science. You might ask me, hey, what do you do as part of this? All right. As part of this, we have come up with, bunch of programs or bunch of tools and libraries and techniques, which will actually help you not just get a job, but also implement real-time projects. Now, let me explain further. So with respect to programming languages, one needs to have knowledge about Python. R is, okay, an add-on. It's not a must-have today, but good to have. Spark is needed because you need to in the training setting, you might have a very small data set to work upon, fine. But in the practical setting, the data sets that we have will be huge. And the moment you load that data into Python or any other tool, your system might crash. You might not even be able to process basic analysis. Given this context, one needs to have knowledge about Hadoop and Spark. And then, and again, in the practical settings, when you work in the company, no customer would send you the data in Excel or CSV format. No one would do that, right? Then what would they do? They will place their data in the databases, either SQL or NoSQL database, and they will give you access only to limited variables, limited data, which is needed for your analytics. You should be able to write basic queries to pull the data and then start working on that. So this is how it works, friends. Ideally, there are multiple scenarios, but one scenario is this. At the customer end, they will have a database with complete data. You as a performing organization, say you're CST, a company, and I'm making up some name. Instead of TCS, I just did this, okay. Or SCT, the reverse of TCS here. Okay. Say you also have a database and infrastructure. Okay. Customer would only allow you either to directly connect to their servers and work directly on their database, or customer might send only the appropriate data for your analysis. Whatever data you need for your analysis, only that data customer will send onto your server, and team of data scientists will connect to this server and then work on the data. You will not even be allowed to download the data on your computer, right? So from your computer or from your laptop, you are expected to connect to this server or this server and work. That means knowledge of databases is mandatory. You need to have that knowledge. Next, we also have Python libraries. Well, there are a plethora of libraries which exist. These are a few which are required. And since Python is open source, a lot of people are contributing to the community. You as a data scientist or a data analyst need not write bunch of lines of code. You need to make use of the libraries. When, say, TCS gets a project from ICICI Bank as an example, then there will be timelines that you need to complete the project within 1 hour, for instance. So, sorry, 1 month, for instance. So the timelines are fixed that within 1 month, you need to complete the project. If you try to do everything right from scratch, time would not be sufficient. So you should make use of the libraries and the functions within that. To that extent, you need to have the knowledge to reuse, if not writing line by line. Okay. And when you join any company or when you get started on data science projects or data analytics or whatever be the data related project, you'd be working on projects. So you need to have knowledge about project management tools. Okay, possess some project management tool, project management framework. And the framework which is extensively used is CRISP MLQ. Cross-industry standard process for machine learning with quality assurance. And when you work on project, you're not the only person. There'll be a team of data scientists who work, right? And when there's a team of data scientists who work, you need to collaborate. You work on some portion, another person works on another portion. When you collaborate that, you need a software using which you collaborate with one another, and that's Jira software. Okay, Next. Here are a few other things that one should have knowledge about. Either Tableau or Power BI, which are business intelligence tools, which are extensively used in data analytics, and deep learning libraries, which includes Keras, TensorFlow, PyTorch, OpenCV. These are needed. Okay. And the one thing which 99% of the people, one of the research articles says that 99% of the people who are getting trained on data science have absolutely no clue on how to deploy the model in production. You obviously, if you're building, say, loan default prediction model, who are the people who will apply for loan? Out of them, who will default, meaning not repay the loan? And then for that, say you have written lines of code and you have built your machine learning algorithm. To the bank employees who should start using your model, would you give them the lines of code and say, hey, I built the model. You also learn Python? Because you'll have to run Python code and then figure out whether a person will default or not. No. To the end user, you need to give an interface, be it mobile application or a web application or some application on which they can just submit the data and they get the output. This knowledge people are lacking severely, and hence, despite getting trained, they're not able to get a job or they're not able to do the projects effectively in their organizations. So deployment platforms is extremely important. Both on-premise means the company for whom you're doing the project might be having their own data center, or on cloud. On cloud means you have Amazon, you have Microsoft, you have Google, you have IBM, so on and so forth. Deploying on that also is equally important. We have data IKU, Python Flask, you have Fast API, you have Python Streamlit, you have Waldo, Vertex AI, Neptune AI, Heroku. You have a bunch of tools on which your model can be deployed. Having knowledge of these will certainly today help you get a job instantly. Having these kind of names on your resume would help you get your interview scheduled. Getting your resume shortlisted becomes easier, because out of 100 resumes that they see, probably one resume will have these kind of deployment tools. Because until and unless you have practical exposure, you'll not be able to handle these. Okay. Or no one will be able to train you until they are real data scientists. And machine learning on cloud is also becoming extremely famous. And you know what? The world is moving towards zero programming machine learning models. That means to build machine learning models, you need not even write a single line of code. A non-programmer, a non-IT guy can build a machine learning model within seconds. Within seconds, they can do that. Yeah, so that's the power of auto ML. Since this is going to be the future, adding these skills would actually help you be more futuristic. So what is the role that people are usually aiming for? Data science, machine learning, so on and so forth, which is all about predicting the future. Then why don't you predict your own future, your own career, right? So predict your own future by having knowledge about what would happen next with respect to this field, so that no recession touches you. And there was one article which I was of late reading, in which people were saying that no organization wants to get rid of an employee who is worth. Even during recession, companies want to run the show. So they'll not get rid of you as long as you are relevant. So become relevant. Okay. So I was talking about this project management methodology, which is very important, friends, because until and unless you understand how to handle a project end to end, you would not be in a position to solve business problems in the space of data, be it data science or machine learning or artificial intelligence, etc. This is something which is very much needed end to end. And what about data engineering? You missed out that part. Data engineering, ML ops, you told you'll explain that. Yes, I'm coming there. The reason why I told you about deployment tools, etc., was for a reason. So while these are all the various things which you have to take care of as part of your CRISP MLQ framework, here we have this deployment part. What is the role of a data engineer? Data engineer is a person who will ensure that the data comes from various data sources and it gets resided in a database. Okay, so let me use a laser pointer. So you have data coming from social media. We also have data coming from IoT sensors on a lot of data science projects. And a lot of people also extract the data from web sources. And you have flat files such as some organizational database, Oracle database or Microsoft, etc. You get the data. That data would come and reside in a database. And this part is called as data ingestion. Predominantly, a data engineer is a person who focuses on ensuring that the right data is available for your data analytics team or data science team or machine learning team or AI team. So data engineer would come in here. Then a data analyst or a data scientist would take this raw data. They will pre-process the data. They generate reports, dashboards, etc. If it's data analyst or a data scientist would build the models and they will evaluate the models. Then comes the deployment part. Traditionally, a data scientist would stop there. I built the model. It's giving me good accuracy. There we go. My job is done. And data scientists would then hand it over to the software engineering team. Software engineers have less knowledge about machine learning and all that. Their job is to build a web application or a mobile application and then ensure that the end users can access the model that you have built. But today, there is a new role which has emerged, and that is called as machine learning operations. Very key role and very powerful role, and data scientists have to possess this knowledge. Again, the same thing, friends. Economies of scope. The more you know, the more you get paid. The more you know, less are the chances that recession will touch you. Okay. So if a person can do the job of a data engineer, ML ops, and data science, why do I want to get rid of him? No matter what, I need that person on the team. So we have ML ops, which is all about deploying the model in production, productionizing the model. So for that, you need to have knowledge about various deployment tools. There are something called as containerizers, which will store all of your code, etc. Okay, and once you deploy the model, either on premise, that is, your customer might have their own data center with the servers. You might deploy a model there. And from there, the model can be accessed using a mobile application or a web application or your organizational application. That means if you build a, say, loan default prediction model, you give an application wherein people can enter age, gender, income, educational qualification, etc. of the new customer who has applied for the loan. And the moment they click on submit, for instance, they get the result. that, hey, there is 90% chance or probability that this person who has applied for the loan will default. Then what would you do? You will reject the loan. For taking this decision, they need an interface which can be easily accessed by the end user who is using this, as opposed to giving the code. Right? You cannot expect the bank employees to learn Python programming now just because you built a model, machine learning model. Yeah. So, and one more very key thing with respect to MLOps is that you don't deploy a model and forget. That's not what we do. You take the deployed model, and then whenever you get the predictions, you store the results back in your database. Okay, the results, you store them back in the database. And you continuously monitor and maintain your model so that whenever updates have to be done, you quickly do that. It won't be something like you build a model and it will be applicable for the next 10 years. No. Whenever there are significant changes, you have to update your model. For example, people use this PEST L also. Whenever there is any political change or economic change or social change or technological change or environmental change or legal changes, that would trigger a model updation. Hence, you need to constantly keep monitoring and maintaining the model, and also look at data drift, model drift, concept drift. There are a bunch of things which exist. Next, you also need to focus upon to become a data engineer or MLOps expert, or to become a very good data scientist. You need to also have knowledge about cloud-based deployment tools. Because you as a data scientist cannot be rest assured that you'll get a job just based on the machine learning algorithms, etc. No, friends, the world has evolved. The sooner you evolve, the sooner you start progressing according to the changes and the industry expectations, the sooner will you get a job, or the sooner you get higher salary. So it's all interrelated, right? So we'll have the database. From that, you take the data, you build the machine learning model, deploy it. Okay, while you deploy it, again, so as a data scientist, you also need to think about being futuristic. It's not about just building a model and building the prediction models. It's also about interacting with your business, interacting with the customer for whom you're building the model. And you should try and understand on what will be the progression for them. Okay, what do I mean by that? For example, if you're, say, building a chatbot, AI-driven chatbot. Today, for example, when you build the model, maybe 1,000 people are using the chatbot concurrently. In parallel, 1,000 people are using. Fine. And your model is, say, working well. Your chatbot is working well. The moment you ask a question, automatically response comes. Say it became a success because of your business strategies. Or if you check with your business or the customer might say, I want to have 100% growth in the next 6 months or in the next 3 months. Maybe they'll have some plan in mind. Based on that plan, you have to build your application. Okay. Tomorrow, if 100,000 customers start using, would this chatbot still support, or will it crash? So you always need to think about from business aspects also. And when you speak on these lines to the interviewers or work on these lines, success rate will increase of projects and also getting jobs. Either of these will be the objectives. So I'm touching upon both. So the single point that I'm trying to drive here is scalable. Building a machine learning algorithm is not sufficient. Building a machine learning algorithm which is scalable is the key. Okay, you need to build a scalable machine learning algorithm. Okay, so how do I become a successful data scientist or a data analyst or a machine learning expert or an AI expert or a data engineer or an ML ops engineer? For all of these things, there's only one solution that I can think about, and that is related to swimming. I keep giving this example to people that if you want to learn swimming, no matter how many YouTube videos you watch, you can use a keyword, best way to learn swimming. And you can watch all the videos available on YouTube. Then you can go to Google and search best books to learn swimming. You can read all the books. But ultimately, the moment you get into water, you'll drown. Why? Because you did not practice. It is as straightforward as that. Until and unless you get into the water and swim, you won't learn swimming. On similar lines, any of these data professions that we are talking about, be data analytics or data science or machine learning or AI or data engineering or MLOps, one has to practice. Without practice, you cannot see the light at the end of the tunnel. Period. Okay, so, and I would like to quickly play this, and then after this, I'll take a few questions. That's about our company. So I thought I'll quickly tell you, we are NASCOM Future Skills member. We have been winning a lot of awards of late. We have won a lot of awards in the past as well, right? And we have been termed as the best training institute in different locations, different regions in Bengaluru, Hyderabad, Chennai, so on and so forth. And Google reviews speaks volumes about the kind of quality that we have. A lot of awards pertaining to the projects that we are doing. It's not a training organization alone, friends. We do a lot of projects. And our folks who are getting trained through us are actually working on real world projects. And that is why there are a lot of success stories associated. Okay, that's me and a lot of news channel scholars, and then we do a lot of work in the space of media as well to help people understand the next level of upskilling. That's our Telangana IT Minister KTR. We receiving an MOU from them, and then we also have another thing which is coming up hopefully.
Thank you so much, Bharani. This was a really edifying session.
Right.
I would request all the attendees, if you have any questions, to please put them in the Q&A section. I think we got some of the questions on the chat, but they've gone up now. So while the questions come up, Bharani, this was really good. And it is really good to see how AI, a foundational technology, is so applicable to pretty much everything under the sun right now. And how important it is to understand what exactly it means. It is more like an umbrella technology rather than just, a very specific vertical per se. So I have a question. What is the difference between strong artificial intelligence and weak artificial intelligence?
Okay, so Nipun, any artificial intelligence application which is able to solve the business problem, would be considered to be a successful AI implementation, right? It's not about accuracy. You might end up building a model with 98, 99% accuracy, but it might become meaningless for business. It's something like operation is a success, but the patient died, right? So any application which is able to solve the business problems is a successful data artificial intelligence implementation. That's, I think, in your exact terms, that's called a strong.
Thank you, Brani. I think that is great. Once again, thank you for your time. And if there are any more questions, we will answer them and come back to you. But we have one right now from Ritesh. To start in AI, in any way, Java knowledge helpful?
Yeah, if you have programming knowledge, not just Java, C, C++, or any programming knowledge, it would be an added advantage because the go-to programming language today is Python only, Ritesh. Okay, given that it has a lot of libraries, but Java has its own speed in comparison to Python, but the kind of libraries, etc., that we have on Java with respect to building AI applications is extremely limited. So the go-to programming language will be Python. And to answer your question directly, yes, having knowledge about Java would help you learn Python better, but Python is a go-to programming language.
Okay. Thank you so much once again, Rani, and thank you so much, everybody, for joining us. Let's see you after lunch. And the next session is at 2:30. Do join us back again and stay tuned. Thank you so much.
Thank you. Thank you so much. Bye.